All right, how do you get a team to work together perfectly when they're all basically blindfolded and can't talk to each other? It sounds like a riddle, but it's one of the biggest challenges facing AI researchers today. And the solution they've found, well, it's pretty ingenious. Let's break it down.
So picture this, a team of rescue drones flying over a disaster zone. Each one can only see a tiny piece of the chaos on the ground, and to make it worse, their communication is totally jammed. They're flying blind, but they have to work together to save people. I mean, that sounds pretty much impossible, right? Well, figuring out that impossible problem is exactly what we're going to dive into.
Okay, so let's really dig into the challenge itself. This whole thing is called blind cooperation, and it's a fundamental puzzle in AI that is, well, surprisingly tough to crack.
So, here are the ground rules for our team. First off, they all have the exact same goal. But, and this is a big but, each one has a severely limited viewpoint. That's what's known as partial observability. On top of that, they're in total radio silence. No texts, no calls, no communication at all. The only thing they can do is act on the tiny bit of info they have and hope that it helps the whole team score points.
You know, the first crack at solving this was, well, it was basically to teach the AIs to just guess. And as you can probably imagine, when things get serious, just guessing doesn't cut it. So this old method, it's called agent modeling. And really, it's like trying to solve a 1,000-piece jigsaw puzzle when you've only been given one single piece. You'd spend all your time and energy just trying to imagine what the entire picture looks like. That's literally what each AI was doing, trying to reconstruct the entire world from its one tiny isolated perspective.
And that's exactly where this whole approach just falls apart. When you try to guess everything, the AI gets completely bogged down in useless information. It's just noise. It's so focused on building this perfect, complete picture that it never actually learns to focus on what matters for the mission. It doesn't find better ways to cooperate. Yeah, clearly this was not the way to go.
Okay, so what if, instead of trying to guess everything, the AIs could learn to filter? A breakthrough approach called SMPE2 is all about creating a smarter, much more focused belief about the world.
The very first piece of the puzzle here is giving each AI something called a belief representation. So forget trying to build out that whole jigsaw. This is more like giving each agent a curated cheat sheet, a compressed summary of only the hidden information that's actually going to be useful for its next move.
But you might be wondering, how does it know what's actually useful? Well, that's the second brilliant piece of this, AM filters. You can think of it like a learnable spotlight. The AI learns to shine this light only on the most critical information, and it filters out all that other distracting noise. It's basically being trained to find the signal.
So what you end up with is this. You take all that chaotic, messy information, you run it through this smart filter, and bam, you're left with a clear, focused target. The agents stop wasting time and energy guessing about everything and instead build a lean, efficient idea of what actually matters for success. It's all about working smarter, not harder.
But wait, a smart filter? That's only half the story. The really clever part, the bit that's kind of counterintuitive, is how these agents actually push each other to get smarter. I love this part. They call it a friendly adversarial nudge.
Okay, so here's how this friendly nudge actually plays out. It's a loop. Imagine one agent finds something new and important. It gets a little reward for its curiosity. But here's the twist. Its discovery immediately becomes a challenge for the rest of the team. The system basically says, hey, your buddy found something you missed. You need to update your map of the world. This forces the entire team to constantly learn from each other's discoveries and level up their collective intelligence.
And this quote from the original research paper, it just nails it. The agents are adversaries only in the sense that they're constantly challenging each other's blind spots. The goal isn't to beat each other. It's to help each other build a better, more accurate map of the world so they can win together. It's collaboration disguised as a challenge. All right, so this all sounds fantastic in theory, right? But the big question is, does it actually work in practice? Well, let's take a look at the results. In the first test, a simple navigation task, the agents had to spread out to cover different landmarks. The teams using this new SMPE2 method, they consistently crushed the other state-of-the-art approaches. Because they could form better beliefs about where their teammates were going, their coordination was just on a whole other level.
Okay, but this next one? This is where things get really impressive. In a super complex foraging task, the older methods just completely failed. They couldn't do it.
But the SMP X2 agents? They didn't just do better, they completely solved problems that the entire research community had considered to be open challenges. This isn't just an improvement, folks. This is a genuine breakthrough.
And to round it out, they tested it in a simulated warehouse. You know, a task that needs a ton of coordination to avoid robots crashing into each other. And guess what? The results were exactly the same. SMP2 blew all the other methods out of the water, proving this approach works across all kinds of complex situations. So look, this isn't just some cool experiment that works in a lab. A breakthrough like this really opens the door for these smarter AI teams to start tackling some major real-world problems.
And the potential applications are just huge. We're talking about fleets of robots in warehouses working in perfect harmony, self-driving cars that seamlessly coordinate with each other in dense traffic, and yeah, even those search and rescue drone teams we started with. This research gives us a real path forward to making these systems a reality.
So if you take one thing away from this, it should be this. This new method essentially gives AI teams two superpowers. First, a filtered focus that lets them see through all the noise and lock onto what really matters. And second, that friendly adversarial system that constantly pushes them to explore, learn, and get better as a cohesive unit. And that leaves us with a pretty incredible thought to chew on. We've just seen AIs learn how to cooperate effectively while they are, for all intents and purposes, blindfolded and gagged. If they can accomplish this with such extreme limitations, what truly massive, complex challenges are they going to solve for us when we finally let them see?